In the previous video, I proposed that the electron itself is a mathematical particle given by this formula Fe. The formula is the geometry of two dimensionless constants, alpha, the fine structure constant, and this omega, and so is also dimensionless. We can construct this formula from objects Al as ampere meters, and from the time object t. Although these objects have scalars, here I'm using r and v, the scalars and units cancel to form Fe. So Fe is dimensionless. This also means that we can do the reverse. Start with Fe and from it extract those objects Alt. We also have a mass, but this might be supplied by the universe itself. This is the story of black holes, but that's for another video. So we started with Fe, and now we have these five components, M, A, L, T, and Fe. If we look at the solutions in this table, we see that wavelength combines Planck length L and Fe. If we solve Fe, we get 10 to the 23, which means that the wavelength of the electron comprises 10 to the 23 units of Planck length, this object L. The frequency of the electron becomes 10 to the 23 units of Planck time. The electron mass formula, however, shows only 1 unit of Planck mass. What we can surmise from this is that the electron oscillates between the Al electric state, these Al objects, which give the electron its electric component. The Al objects then combine with time object T and collapse. The electric electron is now gone for 1 unit of time. And during this unit of time, the electron center, which is a unit of mass, is exposed. The electron is now mass. This means the electron does not exist at any 1 unit of time. Rather, the electron is an event that oscillates over time between the electric state, duration 10 to the 23 units of time, and the mass state, duration 1 unit of time. This is not a wave-particle duality. It is an electric wave-to-point mass oscillation at the Planck scale. As analogy, if 1 unit of time is a frame, then the electron is a movie, and 1 frame does not a movie make. The electron movie requires 10 to the 23 frames and is constantly replayed. The quantum level, a planetary level, including gravitational orbits, are simply the averaging over time of discrete events occurring at the Planck scale. I will look at this in more detail when we do gravitational and atomic orbit tools. There is a formula to measure energy, E equals hv, this h, Planck's constant. We can think of as a unit of energy. It has a fixed value. So what is more interesting to us is this f, which is the frequency of occurrence of this h. The more frequently f occurs, the more h's, and so the more energy. This formula E equals hv refers to the electric wave state. There is another formula to measure energy, E equals mc squared. The c term is the speed of light. This term has a fixed value, and so the m term must be the frequency term. M is not the mass of the electron, rather this m is a measure of the frequency of occurrence of the mass object m, which is their Planck mass. In other words, mass is not a constant property of the particle. As for every wave state, there is a mass state. Then E equals hv equals mc squared. And so the energy of the particle can be measured by the frequency of occurrence of either the wave state or the mass state, as the answer will be the same. They're just different sides of the one coin. If a particle has a short wavelength, then the mass state will occur frequently, and the particle will be more mass-like. A long wavelength, the particle will be more wave-like. As gravity occurs between the mass states, and as the mass states occur seldom relative to the electric states, then gravity will appear weak when averaged over time. But if measured at unit time, we find gravity is stronger than the electric force. Again, how this works is the subject of the gravity video. Our sum universe is dimensionless. This also means that it must be charge neutral. So the number of plus charges, such as found in protons, must be exactly the same as the number of minus charges, as found in electrons. This means that every time a minus charge is formed, a plus charge must also be formed to balance. Magnets have a north and a south pole. A magnetic monopole would be a magnet with only one pole, north or south. The units for the magnetic monopole are the ampere meter, which is our electric component, that Al. The proton has 3 quarks, 2 up and 1 down. The electron has 3 monopoles, if we talk about the exponents. The proton has exactly the same charge magnitude as the electron, although a plus where the electron is minus. However, the proton charge comes from its quarks. So we have to ask if the electron also has quarks, which is a sensible question. It would explain why the charges on the proton and the electron are the same magnitude. The charge on these electron Fe comes from this magnetic monopole Al component. I won't go into details that can be found on this link. But an Al configuration would be equivalent to a d quark. We can make matter and antimatter. The antimatter electron is called a positron. The positron appears to be identical to the electron. So it is a puzzle why our universe has only matter, whereas all the antimatter. However, when we try to make the charge configuration on our positron, we end up with what appears to be 2 up quarks and 1 down quark, which is the charge configuration found on the proton. In all respects, the positron is identical to the electron, excepting that its internal charge configuration appears to be that of the proton. Are our protons therefore modified positrons? Could this explain the missing antimatter and why the universe is electrically neutral? These quarks are the Planck units ALT, and this means that all the information needed to make a complete electron, or positron, is encoded within this formula Fe. Another simple and elegant solution from our program.